Okay, just coming back, same application, or sorry, different application, but same screen. I haven't changed anything. So let's just get back to where we were. We're going to null. Alright, there's our 35, there's our 45. Here was our same piece, that 40% conductivity, there it is. So, same screen, that kind of orients you to where we were last time. Now I want to switch gears and go to conductive coating thickness sample here. Okay, so you can see that we've got 3 thousandths, 6 thousandths, 9, 12, 15 thousandths worth of copper. So what I'm going to show you here is this. Looking at that, there's our screen. I want you to watch me put this down on here so you can at least see what I'm doing. Here's my 3 thousandths. Alright, now we're back over here. I'm going to null on that 3 thousandths. Lift up. There's my lift-off line. Okay, I'm going to go to 6 thousandths, 9 thousandths, 12 thousandths, 15 thousandths. Alright, so we've got some stuff there. It's not very pretty, but it's something. So we want to null on that. Lift up. There's our lift-off line. I want to take this stuff, go back to my divisions here. On my X null, I'm going to move over to about negative 2.0. Because I was at 2.0 over here, I want to move to negative 2. Renull. So there's my 3 thousandths. There's my 6 thousandths. There's my 9 thousandths. There's my 12 thousandths. We're not quite far enough yet. There's my 15 thousandths. Now, some people do this different ways, and that's completely fine. I'm not trying to say that this is the exact right way. I'm just saying this is one way of doing this. 3 thousandths, 6, 9, 12, 15. Okay, we're still maxed out. So now let's take our, there he is, rotation. Let's see if I can get it all. That's close right there. Let's renull. There's our 3 thousandths, 6 thousandths, 9 thousandths, 12 thousandths, 15 thousandths, just inside the screen there. So let's go back to the board here, right there, go back to our locus and say this. If we get rid of all these different impedances now, we're back to just looking at a thickness curve. Okay? Just trying to make you realize, here's our resistance, resistance, I got ahead of myself, resistance, inductive reactance. We nulled up here, there's our first liftoff line. Okay, our second one's down here, this is 6 thousandths, here's 9 thousandths, here's 12 thousandths, here's 15 thousandths. Okay, that, let's do this. All in thousandths of an inch are all coming from what we just drew a minute ago when we drew this. Okay? Vector diagram again, there's our resistance, there's our inductive reactance, there's our thickness curve, and if you've been reading in your book, you see a little hook thing like that. If we had an actual, I guess, sliding thickness gauge, we would be able to see this whole line and that right there. So let's kind of take a look at that. It's not going to be near as pretty, but we can at least see what that is. I guess let's put some references on it here. Let's say, might be the best way to think about it, 0.003, 0.006, 0.009, 0.012, 0.015. Okay, again, all inches, all falling right on that curve, except now you're just not looking at these lines right here. Okay, now you see them, but before we were just looking at the thickness line. Okay, so that's all we want to see now. So let's just do that. Like I said, I know it's not going to be that pretty, but we just want to see that. Let's go back to our scope. There he is. So, there's our samples. Okay, this is what I'm going to do so you can visualize in your head what I'm doing. I'm just going to scan across, just like this, to the different thicknesses. Then I'm going to scan backwards, like this, but change my null point. So I'm going to do this, scan across. You're going to see some jagged lines, but that's okay. So let's go null. There's my liftoff line. Okay, Up, there's my 6,000s, there's my liftoff line. Up, there's my 9,000s, there's my liftoff line. Whoops, I guess if I stay on the part. There's my 12,000s, there's my 15,000s. Okay? All those little hooks at this point are just me jumping from thickness to thickness is all. But now, if we re-null that and erase, push the right button, there we go, re-null, you can see from there all the way to here how those are connected by thickness. Realizing that the thinner I get, okay, on my conductive coating, the less conductivity I have. Okay, this is copper on top of aluminum. So the less thickness I have, the less conductivity I have. Just like we said before, the farther you fall down on this line, the more conductivity you're going to have. Okay, just a basic thought process there. That if we went over here, we might be able to say same thing. We've got just a regular thickness sample. Okay, 50 thousandths, 10 thousandths. Let's get it so you can see it. Okay, thickness. So let's just do that. Let's move our null point. Actually, let's just null and see what happens. So there's our 10 thousandths thickness, 20 thousandths, 30, 40, 50. See, we're way off screen here. So we're going to change our null point down to the bottom right hand corner. We're going to go way down. We're going to be about negative 4.5. We're going to go to our X null point and go over to about 4. Alright, now we're going to null. There he is. There's 50, 40, 30, 20, 10. But you can't see 20 or 10. So we need to shrink that back down. So let's go here. We're at 30 dB gain. Just because of our frequency, without changing the frequency, I'm just going to lower the gain. Same application. Okay, different application I should say, but showing you the same thing. There's 50, 40, 30, 20, 10. Alright, so we can blow that up a little bit. Let's go to 25 dB and see what it does. Because we still want it big so we can see the thousandths of an inch difference. 50, 40, 30, 20, 10. Much better. So 10, 20, 30, 40, 50. Awesome. So again, we just blew up the edge of it, but now we can tell just by how this looks, we can see our thickness curve. Okay? Re-null. There's 50, 40, 30, decreasing conductivity, 20, 10. That's the least amount of conductivity on this sample. Okay? 10, 20, 30, 40, 50. There it is. Quite simple. Okay? I know it seems kind of weird, kind of difficult. Not necessarily. I mean, depends on where you've been, where you came from. But all I'm trying to get you to see in that video is how thickness changes affect conductivity, which they do very much so. Okay, that was all coming off of this piece right here, this thickness gauge, and that's just 30, 40, 50 thousandths. Okay, over here, this is thickness of copper on top of aluminum. So we're just looking at thickness change versus conductivity change. Come back over here, thickness change versus conductivity change. So something to kind of think about there. On top of that, this week, you should have already been through the inductive reactance calculations. Inductive reactance, resistance, all that stuff, and then with the standard depth of penetration thrown in there, so you can see where and how those all come together and where they come from. So if you have any questions, again, you know what to do. Feel free to contact me, email me, do whatever, so that way we can get in touch and get this stuff all thought of and straightened out. Anyways, next week we're going to be looking at bolt hole inspection, and then we'll look at some tube inspection. So something to look forward to next week.